everybody, today I'm going to show you how to help your child to learn operations of fractions under 5 minutes using the Macdonald, Burger King and the KCF methods. Now there are 4 operations of fractions that every student needs to know and be able to perform. However, the problem is sometimes they can get confusing even for adults. So here's a simple way for you to remember what you need to do during the operations. Now this method has no mathematical basis or whatsoever. They are just to help you to remember how to perform the operations. Okay, so let's talk about the addition and the subtractions of the fractions, whereby we're going to use the Macdonald methods. Now why McDonald's? Because it sounds like making denominators the same. I know it's not exactly the same, but let's have a little creativity and imagination so that by using this method, it will help us to remember the techniques more easily. So let's proceed to Macdonald some fractions, shall we? Alright, so let's take a look at some examples on how we should use the Macdonald methods to apply onto the addition and the subtraction of the fractions. Now over here, we have a fraction of 5 over 6 minus 2/3. Now to make the common denominator, you can see that 6 will be the common denominator. Now for the first fraction, we're going to keep the numerator of 5. So let's write that down. Now on the second fraction, as you can see that the denominator has to be made to a number of 6, we have to multiply the denominator of 3 with 2 and the numerator with a number 2 as well. So as a result, this gives you a numerator of 4 over 6. Now with this, we can subtract the fractions and that will get you to 1 over 6 and that is the answer. Okay, let's move on to the second example where we have this fraction of a half plus 3 out of 8. Now as you can see from these fractions, the denominators are different. So once again, you're going to make the denominators to be the same to apply the Macdonald's method. So what is the common denominator? And that will be 8. Now in order to make the first fraction to have a common denominator of 8, we have to multiply 4 to the number 2. And when we have multiplied 4 to the denominator, we must also do the same method by multiplying 4 on the numerator. So this gives us a new fraction of 4 out of 8, which is equivalent to half. Now on the other hand, for the second fraction, we're going to keep this denominator 8 to be the same as the second fraction. So therefore, this gives you 3 out of 8. So what we do to the numerator, you just have to sum up the numerator. 4 plus 3, that gets you to 7. And hence, the final fraction will be 7 out of 8. Okay, let's move on to the third example, whereby we have half minus 3 out of 8. Now, as you can see from these fractions, the common denominator will have to be made as 8. Now, in fact, these fractions are very similar to the previous example. It's just that we are looking at the subtraction of the half and the 3 over 8 fractions. So, once again, you're going to make them as a common denominator of 8. And what shall we do to this? We're going to multiply by 4 to the number 2 to make it into a denominator of 8. And we're going to do the same thing for the numerator as well. So this gets you to 4 out of 8. Now for the second fraction, we're going to retain the fraction because it already has the same denominator. So that gets you to 3 over 8. So what is 4 minus 3 on the numerator? It will be 1 over 8. And that is the final answer. Okay, now let's move on to the last example to see how we can apply the Macdonald methods in the additions of the fractions. Okay, let's say we have half plus 3 out of 7. Now what shall we do to the denominator again? We have to make them into a common denominator. And you can see that the common denominator between 2 and 7 will be 14. So what you have to do is, you're going to write the 14 on the denominator for both the fractions. Now for the first fractions, in order to convert 2 to 14, you need to multiply by 7 on the denominator. And do the same for the numerator, so this gets you to 7 over 14 as a new fraction to represent the fractions of half. And for the second fraction, to convert 7 denominator to 14, you have to multiply by 2. So So do the same for the numerator. You're going to multiply the 3 by 2, so that gets you to 6. And as a result, just sum up the numerator. So 7 plus 6 will be 13, and divide by 14. So the final answer will be 13 out of 14. Okay, so this is how the MacDonald's method should be applied to the addition and the subtractions of the fraction. I hope this helps for the students. Alright, so what about the Burger King method? Now for the Burger King method, we're going to apply it onto the multiplications of the fractions. Okay, let's look at here. We have two fractions, which is the fractions of half and multiplied by the fractions of 5 over 8. Now, when we do the multiplications of the fractions, we have to take the numerator of the first fraction to multiply by the numerator of the second fraction. Similarly, we have to multiply the denominator of the first fraction with the denominator of the second fraction. And by drawing the arrows, does it remind you of a burger from the Burger King? Alright, so that's how we apply the Burger King method. Now what would be the result for this? As you can see, 1 times 5 is equivalent to 5 on the numerator. And what about the denominator? 2 times 8, it gets you to 16. So that gives you a final answer, which is 5 over 16. And once again, let's try another example where we have a fraction of half and we multiply by another fraction of 4 over 7. 4 over 7. So from here, applying the Burger King method again, multiply the numerator, we get 1 times 4, which gives you 4, and multiply the denominators of both the fractions, 2 times 7, it gives you 14. And hence, the final fractions will be 4 over 14. Okay, and the last method that I'm going to share with everyone is the KCF method. So it sounds like KFC, but in fact KCF stands for keep, change and flip, which we're going to apply it on the division of the fractions. So how does it work for this, this method? Okay, let's take one example where we have 1/3 divide by 2 over 5, or 2/5. Now first of all, we have to keep the first fraction, and that is 1/3. So you just copy down the fraction, 1/3, and then you have to change the division sign to the multiplication sign. Alright? Now what about the last step? For the last step, you have to flip the second fraction, which gets you to 5 over 2. Now flipping the second fraction simply means that you put the denominator on the numerator, and the numerator becomes the denominator. So it gets you to a multiplication of the fractions, and once again, what did we learn about the multiplication of fractions in the earlier example? We have to use the Burger King method, and we're going to multiply the numerator and the denominator. So as a result, it gets you to 1 times 5, which is 5, that is the numerator, and on the denominator we have 3 times 2, which gets you to 6, and hence the final answer will be 5 out of 6. Alright, so let's try another example to show how this KCF method can be worked on the division of the fractions. Let's say we have 1/3, and we're going to divide by 4 out of 7. Alright, so first of all, we have to keep the first fraction, which is 1/3. Next, we're going to change the division sign to a multiplication sign, and that gets you to a multiplication sign here. And what about the flipping part? We have to flip the second fraction, and that will be 7 over 4. So from here, we get a multiplication of the fractions. We have to use the Burger King method again to multiply the numerator and the denominators. So we have this as 1 times 7 to get you to 7, 3 times 4, that gets you to 12, and hence your final answer will be 7 over 12. Thank you for watching. If you need more questions, do check it out on the link below.